Hello and welcome to our next class on mathematics. We are going to continue with our topic, algebraic expressions, equations, and inequalities. In our last lesson, we finished the discussions of equations, where we said that equations are, or algebraic equations, are normally in one form. That is, it consists of three parts, that is the left-hand side, an equal sign, and the right-hand side. We are able to see that you can have equations with pronumerals on only one side of the equation, and some other time we can have linear equations with two pronumerals or on both sides. A good example is when you have 4x plus 2 is equals to x plus 3. This is a kind of an equation that has pronumerals on both sides, that is in the left-hand side and also in the right-hand side. And we can be able to solve this equation by collecting the like terms together. That means we bring x to this other side and we take 2 to the other side. We say that whenever figures cross the equal sign, they're going to change their sign. And therefore, when this x crosses the equal sign to the left-hand side, it will be minus x is equals to 3. When this 2 crosses the equal sign, it becomes minus 2. When you solve the left-hand side, you'll remain with 3x is equals to 1. That is 3 minus 2 is 1. And therefore, you to get the value of x, we divide both sides by 3. You'll get that the value of x is a third. So that is what we were looking at in our last lesson. We now want to introduce linear inequalities. Now, linear inequalities also has another name. We can call them linear inequalities or linear inequations. And linear inequalities are mathematical statements that normally uses inequality symbols. So they are mathematical statements that uses inequality symbols. And these inequality symbols are 4 in number. 1, we have this kind of a symbol which means greater than. We can have another kind of a symbol that looks like that. This means it is greater than, then equal to. So greater than or equal to. Then third, we have this kind of an inequality symbol meaning less than. We can also have another one that looks like that, which is either less than or equal to. Now, these are the 4 inequality symbols that are normally used in coming or in statements of mathematics. Whenever we use these particular 4 inequality symbols, then that particular problem becomes an inequation or what we call linear inequalities. Now, we can be able to represent linear equations or inequalities in what we call a number line. Now, a number line is a straight line that consists both negative and positive integers and also a 0. It's important to note that whenever you're constructing or drawing a number line, both ends should always be open, meaning that they are continuing. And for you to show that, you indicate with an arrow at the end and also on this other end. So it's a line. So we indicate that the figures or the values will be continuing in the right and in the left hand side. We have a 0. On the left hand side, we are going to have negative integers, -1, -2, -3, -4, and it continues. The arrow shows that the integers continues to infinity. Then on the right hand side, we have positive integers, +1, +2, +3, +4, +5, as it continues up to positive infinity. This up to negative infinity. Now this is a simple number line, and we have said it consists of integers both negative and positive, and 0 is included. Now for us to be able to use a number line, it's important for us to understand the 4 inequality symbols. That is the greater than, less than, greater equal, or less than equal to. Representation on number line. Now we normally use an open cycle or circle. We use an open circle when we show greater than or less than. Example. If this is our number line, we have said that for it to be a number line, we must have the negative side and the positive side and the 0 included. Here we have got the positive numbers 1, 2, 3, 4, etc. -1, -2, -3. If we want to show, for example, a statement that is x is greater, we want to begin with this, is greater than 2. We have said we use an open cycle. So you come where 2 is and you draw a small circle. It is going to be open because the number or the value 2 is not included. And you have been told that x is greater than 2. That means x can be any number on the right. That is any number that is greater than 2. That means we advance to the right. So our answer can be 3, it can be 4, it can be 5, it can be 6, up to positive infinity. But it can never be any number below 2. For this one, that is less than, we can have x less than 3. Again, you draw the number line. We have said it's a straight line with arrows on both ends, 0 in the center, positive numbers on the right, +1, +2, +3, +4, negative numbers on the left hand side, -1, -2, -3, -4. Now we have been told to indicate where x is less than 3. Again, because it is less than, we are going to use an open cycle. So we look for 3 on the number line, we locate 3 there, you put an open cycle, then we have been told that x is less than 3. That means x can be any value less than 3. It can be 2, it can be 1, it can be 0. That means we are going towards the left-hand side. Therefore, we draw our arrow to point the left-hand side. Greater than, we go to the right-hand side. Less than, we go to the left-hand side. And remember that for both greater than and less than, our cycle are going to be open, not closed dots or circles. What about if it is greater than or equals to, or less than and equals to? So in that case, we use closed circle for less than or equal to and greater than or equal to. E.g., if you have a case of x is less than or equals to 3, so you draw up your number line. We have said it's a straight line with arrows on both ends. At the center there we have 0, positive numbers to your right, negative numbers to your left. Now, if you want to represent x is less than or equals to 3, again we have to locate on the number line where 3 is. And 3, you can be able to see it is there. So we draw a circle, and you have been told that this circle should not be closed, should not be open, therefore it should be closed. Now, because x is less than or equals to 3, that means x can be any value between 3 down 1. So it can be 3, it can be 2, it can be 1. The reason why we are saying that this dot is closed is to indicate that, or is to show that this value 3 is included. So x is less than 3, so that means the arrow should point on the left hand side. If x is greater than or equals to 2, how can we be able to represent that? Again, we draw our number line, arrows on both ends, 0 in the center, positive numbers on your right, negative numbers on your left. Again, we locate where 2 is, so 2 is here. So we have said you put a dot where 2 is, and you remember that 2 is either greater than or equals to. So that means that our number 2 is included. Therefore, this dot should be closed. And then we check for the direction. We have been told that x should be greater than or equals to 2. So that means the answer can be 2 or any value more than 2, which can be 3, 4, 5, etc. So that means we are going to go on the right hand side. So for less than or equals to and greater than or equals to, we have said we use closed dot. For simply less than or just greater than, we use open dots. Now we have another set of inequations which we call them compound statement or compound statements. So in this particular case, we'll have one number line representing two simple statements. Like for example, if we have negative 2 is less than x, but the same x is less than or equals to 3. How can you be able to represent this? This is what we call a compound statement. So again, for this, if you are to represent it on the number line, you'll draw your number line. We have said for it to be a number line, you must have arrows on both ends. It must have a 0. We must have numbers on the right hand side and also numbers on the left hand side, which are negative. Now we've been told that this value x is greater than negative 2, and at the same time x is less than or equals to 3. So you can first try to satisfy this condition. We have been told that x is greater than negative 2. So you look for negative 2 on your number line. Negative 2 is here. You draw your circle. Now because it is simply greater than, then that means we are going to use an open circle. Then on the right hand side, we have x is less than or equals to positive 3. So we look for positive 3, it is there. And you remember that this one is either less than or equals to. So that means that our dot is closed, or our circle is closed. Now in this case, we are told that x should be greater than 2. That means you must move your arrow towards your right hand side. But the same x is less than 3, so that means you move your arrow towards the left hand side. So you'll find that all these numbers between -2 to 3 will provide you with a solution. These values between here and here are the solution to this particular inequality or inequation. But when you'll be stating your solutions, then -2 should not be part of your answer because it is not included. Therefore, you can be able to say that the values here can begin with -1. So -1, 0, 1, 2, and 3. We point out 3 because 3 is included. We are told it is either less than or equals to. So it can be and part, or it is part of the answer. Now what happens with the sign at the other end of the inequality symbols when you do a division or you multiply by a negative number? Now if you multiply or divide both sides with a negative number, then the inequality symbol is reversed. For example, if you had that 5 is less than 8, this is a statement that is connecting 5 and 8 using an inequality symbol. That means that 5 is less than 8. But what happens when you divide both sides of this equation with a negative number? Like you divide both sides by -1. Then you're going to have it as -5. The other side, you're going to have it as -8. Now, this symbol should change because we have divided by a negative number. So it will change from pointing this side to pointing the other side. And this one now means that -5 is greater than -8. If we had -x is greater than 1, for example, when you divide these values through by -1, then you're going to obtain x. The inequality symbol changes to greater than -1 because you have divided through by a negative number. Another reason why the inequality symbol can change is when you swap those particular numbers. Like we take 8 to this left hand side, we take 5 to the other side, then the inequality symbol again is going to change. So if we swap the sides of the inequality, then the inequality symbol is going to change. Example, if you have 3 is less than 7, then we want to swap these figures so that 7 comes here and 3 goes to the other side. Then we are saying that it will interfere with our inequality symbol, so that we now begin with 7, then on the other side we have 3. Automatically we know that 7 is greater than 3, and therefore the inequality symbol should look like that. So in general, if we had x is less than 4, for instance, when you change or you swap so that you begin with 4, this inequality symbol should also change to be greater than x. We now want to consider a number of examples on how we can be able to solve inequations. Example. Show each of the following on a number line. Part A, we have x is less than 6. So if we come up with a simple statement to represent this, we've been told that x is less than 6. That means we have x. We use the inequality symbol that represents less, which is that sign is less than 6. We have been told to represent this on a number line, so you draw up your number line. Always remember that we must have both ends open. That means it's continuing. We have a 0 in the center, -1, -2, -3, negative numbers on the left hand side, and positive numbers on the right hand side. Now you have been told that you indicate x is less than 6. So we are going to draw a small circle on 6 because that is where our positive 6 is. And then you have been told that x is less than 6. That means it is any number so long as it is less than 6. That means there are numbers on the left hand side, and therefore you draw an arrow pointing on the left hand side. So you'll have represented this information on a number line. Part B, x is greater than -2 but less than or equal to 3. If we were to express this one as a statement, we have been told that x is greater than -2, and at the same time the same x is either less than or equals to 3. So this requires us to come up with a complex or a compound statement where we have been told that x is greater than -2, and at the same time x is either less than or equals to 3. So this is a compound statement, which again we can be able to represent using a number line. So we have both ends open, 0, -1, -2, -3, 1, 2, 3, 4, 5, etc. So we've been told that x is greater than -2. So you come up to where x is -2, you put a circle. Consider this, it is greater than -2. Therefore, it's going to be an open circle. Then on the other side, we'll be told that x is less than or equals to 3. That means you look for 3 and you draw a circle, which in this case should be closed because that particular 3 is included. Now I've been told that x is more or greater than -2. That means you go towards the right side. And x is less than 3. That means you go towards the left hand side. So these values in between are going to indicate our statement. X is greater than -2, and at the same time x is less than or equals to -3. So here, if you're asked to provide solutions to this particular statement, we can be able to say that the answers to this question does not include 2, but anything above 2, -2 up to 3, and 3 will be included, so that we can have -1, 0, 1, 2, and 3. These values are normally referred to as integral values. And they are the answers to that particular linear inequations or inequality. Example 2. Find the solution set for each of the following inequalities. Number 1, x minus 3 is less than 7. Now in this particular case, we are going to apply the same rules that we used when we are solving linear equations. In solving linear inequalities, the same steps will apply. If we have brackets on either sides, expand them first. Now, we need to group the like terms here, and you can be able to see that 3 and 7 are like terms. Therefore, we're going to take this negative 3 to the other side. So for us to eliminate negative 3 on the left hand side, we are going to add 3 on both sides. So we are going to have x minus 3. Because we want to eliminate this negative 3, we add a 3 on the left hand side. Then the inequality symbols remain. Then we have 7 on the other side. Whatever we did on the left hand side, we must also do it on the right hand side. So that means if we added 3, we must add 3 on the other side. So negative 3 plus 3 will give us 0. So that means this one will leave us with x. The symbol remains there. 7 plus 3 is 10. Therefore, the solution to this answer is that x is any number that is less than 10. And we can be able to represent that particular information on the number line. Part B, 5 minus 2x is greater than 3. We can again be able to solve this by applying the same method. That means we collect the like terms together. We must take 5 to the other side of the equal sign of the inequality symbol, and for us to do that, that means we must subtract 5 from both sides. So this will give us 5 minus 2x is greater than 3. Whatever we did on the left hand side, we must also do it on the right hand side. Now when you do that, 5 minus 5 is 0, so we'll remain with minus 2x is greater than. On the other side, we have 3. Subtract 5, it will give us negative 2. So we now have negative 2x is greater than negative 2. Now you see here we have to get the value of x. That means we must divide both sides by negative 2. There's something we said. Whenever you multiply or divide by a negative number, then the inequality symbol should change. And in this case, because we are dividing by a negative number, then the inequality symbol should change. So this one will leave us with 1. So x. We are saying because we have divided by a negative sign, that inequality symbol should change. So negative 2 divided by 2, you will get positive 1. The inequality symbol has changed to mean less than. Number C, d over 4 less 3 is greater than or equals to negative 11. Now, for us to be able to solve this, we must take this negative 3 to the other side. And for us to eliminate negative 3, we must add it on both sides. So this will leave us with d all over 4 minus 3 plus 3 is greater than or equals to negative 11. What we did on the left hand side, we must also do it on the right hand side. Now when you take negative 3 plus 3, you will get 0. So we'll remain with d over 4 on the left hand side is equals to, is greater than or equals to. Negative 11 plus 3 will give us negative 8. Here you have not reached your conclusion. You still need to remain with D on one side. And for us to remain with D on one side, this will give us, that means we must multiply both sides by 4, greater than or equals negative 8. So we multiply both sides by 4 to eliminate this denominator. There 1. This will leave us with B is greater than or equals to negative 32. Example 3. Wendy is X years old and J is 6 years younger. The sum of their ages is less than 30, right? An inequality involving X and solve it. What can you say about Wendy's age? Now this particular question has got two parts. One is the formation of the inequality, using the inequality to form a statement, then we solve it. Then the other case is to state or to give any description of Wendy's age. Now you have been told that Wendy, we have here Wendy, and we have J. You have been told that Wendy is X years and J is 6 years younger. That means he is 6 years younger than Wendy. Now we have been told that when you combine or you find the total or the sum of their ages, that is of Wendy and J, that should be less than 30, and therefore can be able to come up with an inequality to demonstrate that. So when you get the sum of Wendy's and J's ages, it will be X plus X minus 6. We have been told that when you add their ages, you will get strictly less than 30. So that is the first step. We have formed the inequality statement. We need to solve this for us to get the ages of Wendy and the ages of J. When we combine these two like terms, X plus X, we are going to get 2X. Then we take this negative 6 on the other side of the inequality symbol. It will be 30 plus 6. So this will give us 2X is less than 36. That is when you add 30 and 6, we get 36. When solving, you divide both sides by 2 for you to get the value of X. That means that X should be strictly less than 18. Let's see what will be the age of Wendy. Wendy is X years, and therefore is going to be 18 years because the value of X is 18. Therefore J, we have been told that J is 6 less than the number, therefore it's going to be 18 subtract 6. And when you take 18, you subtract 6, you'll get 12 years. So you discover that Wendy's age is 18 years, and then J's ages is 12 years. You can be able to say something about the age of Wendy. That is, maybe Wendy's age is, when you take the fraction or when you write them as a fraction, that will be 18 over 12, and 18 divided by 12 is 3 halves. Therefore, can be able to say that when this edge is 3 halves that of J as a conclusion statement on this. So that discussion brings us to the end of what we have been looking at on linear inequalities or inequations. We want now to look at how we can be able to use formulas or vary formulas in different situations. A formula or formulas simply denotes rules. There are certain rules that are normally put in application whenever you want to find maybe the area, the circumference, the perimeter of a given figure. So you can be able to say that a formula, or which is simply a rule, is an equation that relates two or more pronumerals, A very good example of a formula is that formula for finding the area of a circle. Area of a circle is normally given by pi r squared. Pi is a constant term, which you can be able to say it's either 22/7 as a fraction or 3.142 as a decimal, which has been rounded off. Then r denotes the radius of that particular circle. And you can be able to observe that area is strictly dependent on this part of the radius because pi is constant. So whenever you vary the radius, then you're going to affect the area. So if you want to increase the area, then you increase the radius, because these two can be able to say that they have a direct relationship. Whenever you increase radius, area increases. If you reduce radius, again area is going to reduce. So this is a formula for finding area when you are given the radius of that particular circle. We can have another example of a formula. F is equals to 9/5 C plus 32. We can be able to recall that this is a formula that is normally used to convert degrees Celsius to degrees Fahrenheit. That is, if you are given certain temperatures in degrees Celsius, you can be able to convert it to degrees Fahrenheit by use of this particular formula. So you can say is a formula for converting degrees Celsius to degrees Fahrenheit. Which is normally denoted by letter F. And this one you can be able to solve it when you are given C. Another example of a formula is that one for finding distance traveled. We normally say that distance traveled is equivalent to the velocity multiplied by the time. So in this is a formula for getting distance traveled given velocity. The other name for velocity is speed if it is not in a specified direction, and time. So d, or the distance, is actually dependent on the velocity and time. And again, they have got a direct relationship. Whenever you increase velocity or you increase time, then you are going to increase the distance covered. Again, if you decrease, or if any of the variables on the right hand side decreases, then you are going to reduce the distance traveled. There is also something that we need to understand on formulas. That is what we call the subject of a formula. The examples I've given out or I've shared with you about the area of a circle, how to convert degrees Celsius to degrees Fahrenheit, and the last one on how to calculate the distance traveled when you're given velocity and time, you'll be able to discover that we have one variables on the left and then all the others are on the right hand side. So whenever we express a term to be on its own in one side, then all the others in the other side, will refer that particular variable which is on its own as a subject of that particular formula. So is subject of a formula is a pronumeral, usually sitting on its own on the left hand side of an equation, e.g. a is equals to pi r squared. You can be able to see that we have a pronumeral a sitting by itself on the left hand side of the equation. Therefore, you can be able to refer to this a as a subject of this particular formula. Circumference of a circle is normally given by 2 pi radius. That means we have C sitting by itself on the left hand side, and therefore C becomes the subject of the formula. In this case, we can be able to say that A and C are subjects of the formula. Example. Now, it's important to note that sometimes you can be asked to make any of the pronumeral to be a subject of a formula. Like, for example, in this case, C is equals to 2 pi r. If you're asked to make r the subject of the formula, make r subject of the formula. That means we must have r sitting by itself usually on the left hand side. So in this particular case, for us to be able to make r sit on its own, we must eliminate 2 pi. And for us to eliminate 2 pi, it means you have to divide both sides by 2 pi. So that 2 pi and 2 pi cancels to leave us with r is equals to c all over 2 pi. So if we rewrite this statement, we can be able to say that r is equals to c all over 2 pi. So if you have been given the circumference of that particular circle, you can be able to get the radius by making r the subject of that particular formula. We also call this process transposing. So it's either transposing or making it the subject of the formula. Example, substitute given values into the formula to evaluate the subject of the formula. Number A, S is equals to A all over 1 minus R, and this is when the value of A is 3 and R is 0.4. So this, we need to simply substitute the values of A and R in this particular formula. So you can be able to see that S is on one side of that particular equation, and therefore S is what we call the subject of the formula. So if you want to get the value of S, we'll make the substitution. A, you have been told, is 3. So you replace or you substitute A with 3 all over 1 minus the value of R, which is 0.4. Now this one will give you that S is equals to 3 divided by, when you subtract 0.4 from 1, you will get 0.6. And when you divide 3 by 0.6, you'll be able to discover that the value of S is going to be 5. Part B, E is equals to a half mv squared when the values of m is 4 and v is 5. So again, we are going to substitute for us to be able to get the value or the solution to this left hand side. E is now called the subject of the formula. So E will be equal to a half multiplied. We substitute the values of m and v. M, you have been told, is 4, and v, you have been told, is 5. And we are getting the square of 5. So this one is going to give us E is equals to a half multiplied by 5 squared is 25. When you multiply 25 by 4, you will get 100. When you multiply 100 by a half, you will get 50, and therefore E is going to be 50. Example 2. The area of a trapezium is given by the formula area is equals to a half into A plus B multiplied by H. Substitute A is equals to 12, small a is equals to 5, and H is equals to 4. Then find the value of B. So you have been told that the area of a trapezium is given by a half into A plus B multiplied by H. This one you have been told will give us area. You have been told to make the substitution. The value of A is 5. We don't have the value of B, but you have the value of H, which is 4. When you multiply that, it will give you A, which is 12. If you divide this through by 2, 2 will go there once, it will go into 4 twice. So when we use this 2 to open up our bracket, we'll get 2 multiplied by 5 is 10, plus 2 multiplied by B is 2B is equals to 12. Then we group the like terms together. That means we take 10 to the other side. So we'll remain with 2B is equals to 12. When 10 crosses the equal sign, it becomes minus. Therefore, we're going to have minus 10. So we'll have 2B is equals to 12 minus 10, which is 2. Therefore, for us to get the value of B, we must divide both sides by 2, which will give us 1. Therefore, the value of B, that particular formula, is 1. Let us consider the final example by looking at a baseball formula. So different games normally have different formulas for finding who won. Like if it is in football match, we normally consider the strength of the team by looking at the number of scores they have made, what is their position, how many shots have they made on target, and so forth. We also have formulas for determining the winner in a basketball team, and we call it a basketball formula or basketball formulas. Now, the basketball formula is normally given by T is equals to 3x plus 2y plus f. Each of this pronumeral have got its own understanding or meaning. When we begin with T, T stands for the total number of points. Total number of points. If we look at X, X or the pronumeral X stands in for the number of 3-point goals. We have a 3-point goal in a basketball training or competition. Number of 3-point goals. We have Y. Y is a number of 2 points. Number of 2-point goals. And finally we have F, which is the number of free throws made. Let's consider an example of now we can be able to use that formula to find the total points of a basketball team. Find the total number of points, that is T, made in a game where twelve 3-point goals, 15 2-point goals, and 7 free throws are made. So we say that the formula is T is equals to 3x, x representing the total number of 3-point goals, plus 2y, y representing the number of 2-point goals, plus f representing the total number of free throws. So our total points for this particular team will be 3 multiplied by x, and our x have been told is a 3-point goals, which were 12, plus 2 multiplied by the value of y, which is a 2-point goals. We were told that there were 15, plus the total number of free throws. We were told that this team had 7 free throws, and you can be able to consider that 7 is a constant, it is not changing. So our total points will be 3 multiplied by 12, you will get 36, plus 15 multiplied by 2, you will get 30, plus 7. So this one is going to give us 66, plus 7, meaning that the total points for this team is going to be 73 points. Now this topic on formulas is very important because always can be asked to make a certain pronumeral to be the subject of the formula, and before you proceed to solving it, you must know how to make that pronumeral to be a subject of that particular formula. This brings us to the end of our lesson. Thank you.